Yes, hello students. Welcome to our 8th lesson in this e-learning process. And today, under the topic of moles, we want to look at volumetric analysis, what is called titration, in another word. Now, the objective of our learning today, we are going to achieve two things. One, at the end of this class, you should be able to define the terms used in volumetric analysis. B, that is the second objective, you should be able to identify the apparatus used in the titration process or in the quantitative analysis, that is. So, define the terms used in volumetric analysis, and then at the same time to identify the apparatus used in this branch of chemistry. Now, our subtopic or our topic of discussion is titration. And in titration, we do what is called quantitative analysis. It is a quantitative process. It deals with how much, what amount, quantity. It does not deal with the quality, but it deals with the quantity of a given substance which is used in a given reaction. So titration is a quantitative analysis process that involves the addition of a solution of a known concentration to another solution of unknown concentration. So what are we talking about here? We are talking about a case where you have solution A and solution B. One is known, another one is unknown. Known in the sense that the concentration is known. Can be 1 molar, 2 molar, 3 molar, 0.5 molar. This one, the concentration is not known. Not known. This one is known. So for us to establish, for us to determine the concentration of this solution B, then we must carry out what is called titration. We must carry out a reaction between A and B so that we can use A to verify the concentration of B. A solution whose concentration is known is normally called a standard solution. Such a solution is called a standard solution. So we are going to deal with two solutions here. One is unknown and the other one is not known. Now, let us go to the terms. Let us move to the terms associated with volumetric analysis. The terms that we normally use in volumetric analysis. One of the terms is a standard solution. And I've said a standard solution is one whose concentration is known. It is a solution of known concentration. Whether it is 2 grams per liter, 3 grams per liter, 0.1 grams per liter. Concentration can also be molar, in molarity. 0.1 molar, 2.0 molar, those are concentrations. So when we have a solution, for example, we are talking of solution A, and this A is labeled 0.1 molar, then this one is a standard solution. That is a standard. And in titration, we normally deal with 2 solutions, or sometimes you can deal with 3. But one of them must be a standard, the other one will be unknown. Then there is a second term, number 2, that we call the analyte. An analyte is the solution whose concentration is to be determined. Meaning the analyte is the unknown solution, the one which is unknown, the one that you are trying to find out. What is the concentration of that solution? Or now if you are using solution B, we'll carry out a titration and then determine its concentration. That is the analyte. Now, number 3, we have what is called equivalent volumes. Equivalent volumes. Now, equivalent volumes, these are the volumes of both the standard and the analytes, which react completely. I want to give you an example. An example, like this one is our stand and the clamp. So during titration, we'll be reacting B, maybe, let's say, we have 2 solutions. This one is not known, solution B, unknown. So the amount of A that will react completely with a given volume of B, so let's say B, the volume that reacts is 15 centimeters. And A, the volume that reacts is 20 centimeters. So let us say that 20 centimeters cubic of 0.1 molar of A can completely react with 15 centimeters cubic of B. Then equivalent volumes is now 20 centimeters cubic of A and 15 centimeters cubic of B. The volumes of the analyte and the standard solutions that react completely. That's what we call. Now, so the end of the reaction, you'll be reacting the 2 solutions. But how will you know the end of the reaction? The end of the reaction, which is normally referred to as equivalent point, is normally called the end point also. Yes. During a titration, just briefly, during a titration process, we normally use the stand. So this is our stand. And a clamp. And this burette, the burette, so let me adjust my clamp so that I can make you understand something here. Today we are just going to see the overview of how titration is done. So let me put this one here. We clamp our burette. Yes. So we have clamped our burette like that. Then, like for example, let's say I want to put this analyte here. So let me put the analyte in the burette. Now the burette is graduated from 0 up here, downward up to 50. Though we have some burettes, smaller burettes of 25, 30, but ours is 50. So it is graduated from 0 up here. Remember, for most apparatus, 0 starts down. But for this one, 0 begins up here, downward to 50. Meaning if I fill it, you know I fill it using the funnel. If I decide to fill it, like this, let me just fill it with water. Now, and always you find that it goes past 0. So it is now past 0. but it is supposed to be 0. So how do I move it back to 0? I will take a beaker and then drain it out. Drain the water out from the boiler up to 0. So that is 50 centimeters cube. So let us say that in our burette here, this is our burette, we have the analyte. That is our analyte in the burette. So if we have analyte in the burette, we want to react it with the standard. We want to react it with the standard. So the standard will be placed in a conical flask. So we also need a conical flask. But how do you fill? How do you fill your pipette with the now I'm just using water because just about learning how to do it. Yes. So how? Okay. We will continue this in our next video.